All right, to review the auditory senses we've already talked about, like I said, you'll probably need to know the, kind of the sequence of how things happen. So, like I said before, it is best if you create your own acronym. I found a couple for you, so here's another crazy one. Um, Protangula evaluates exams on ominous charts between hungry architects that always titter. So, the pinna, which is the outside ear, the ear canal, the eardrum, the ossicles, to your oval window, to your cochlea. Remember, very important because that's your inner ear where transduction occurs. A little review. Basilar membrane, hair cells, auditory nerve, thalamus. Remember the part of the brain that processes all of your senses except for? Hopefully you fill that in with smell. Auditory cortex, and then your temporal lobe. So this last part of the auditory notes is just a couple theories on how we hear. The first theory we're going to talk about is the place theory. And so what this says is different frequencies cause larger vibrations at different locations along the basilar membrane. So if you remember the last set of notes, I showed a lot of different pictures of the basilar membrane. Different pitches stimulate different areas on the basilar membrane. So the brain receives these messages and interprets them as different pitches. This theory is used to explain how you hear high frequencies. So if you remember the basilar membrane and the hair cells that wave on it, what place theory says is depending on the pitch, right, higher, lower, middle, whatever the pitch is, a different part of that membrane is going to vibrate. And so whatever parts of that membrane vibrate, then send that message to your brain saying, oh, this is a low pitch or this is a high pitch. I believe some of the videos I'll post will kind of show that as well. So you can visualize it here. All right, so how the different frequencies simulate different areas of the brain. So the top one, if you see the low frequency, so that that vibrates here, low frequency, medium frequency, somewhere in here, high frequency, up here, and obviously anywhere in between. So it could be anywhere, right? It could be here would be one frequency. Here it could be no matter where it is, it's just a higher to the lower frequency that you can hear. And like I've mentioned before, there's apps you can get that can actually measure what frequency, how high frequency you can hear up to. The other theory is the frequency theory. So the frequency theory says basilar membrane vibrates at the same frequency as sound wave. So the higher the frequency wave, the faster the firing of the hair cells. This theory is used to explain how you hear low frequencies. So high tones, the Volley theory, shoot in succession to keep up. So pretty much you got those hair cells, right, that wave, that send a pitch to your brain. Well, the frequency theory says if it's a high frequency, then it's going to wave really fast. And if it's a low frequency, then those hair cells wave slower. And obviously anywhere in between.
Want to hear the most annoying sound in the world?
And here's just another example of frequency theory, a visual for you. Remember, the basilar membrane vibrates according to the same frequency of the sound. So you see where it comes in over the oval window. You got the basilar membrane here, and this is the direction of the wave. Depending on how fast that wave travels, all depends on the pitch of the sound, and then that is sent to your brain. So just remember those two theories, the place theory and the frequency theory.